Hi everyone, welcome to Learn with History YouTube channel. So in this video we'll be treating JAMB Physics question for episode 1, which comprises 20 questions from question 1 to question 20. I want you guys to stay attentive. If you really want to score high in your JAMB exam, especially in physics, stay tuned. This question right here will really help you. So let's dive in. And if you are interested in tutorial, just try this number right here on WhatsApp to join the tutorial. And if you are interested in getting JAMB syllabus for free for any subject, including maths, chemistry, physics, just name it, just try this number right here. You get the JAMB syllabus for free. And if you are interested in past questions, just try this number right here to get it. And if you haven't subscribed to Learn with History YouTube channel, what are you waiting for? Hit that like button and subscribe now as we dive in. But before we dive in, don't forget to subscribe for those that have not subscribed. So once I drop the next episode, you will be the first person to watch this video. Let's continue. Question 1. A car starts from rest and moves with a uniform acceleration of 30 meters per second square for 20 seconds. Calculate the distance covered at the end of the motion. A 6 km, B 12 km, C 18 km, D 24 km. So we can't know our answer now except we solve this question. And before solving any question, we need to know the topic where it emanates from. The topic of this question, where this question is coming from, is motion. And we have 3 formulas to solve this question. Let me write it out. The first one is S equals half ut plus at squared. The second one equals V equals u plus at. The third one is V squared equals u squared plus 2as. So this is the 3 formula. So let's write out our givens. We have our acceleration as 30 meters per second. Our givens. So our acceleration is 30 meters per second square, and our time is 20 seconds. So we are looking for our distance, which is represented as S. So if we check all the formula right here, the one that is suitable to solve the question is S equals half ut plus at squared. The reason is because S is the subject of the formula here, and we are looking for S. And we also have our A, we have our T. So let's just solve it. And our U is 0 meters per second. The reason why our U is 0 is that the car is starting from rest. That's why our U, which is initial velocity, is 0. So let's solve. So our S equals half, our U is 0, multiplied by 0, multiplied by our T, which is 20, multiplied by, so plus, you see plus here, plus our acceleration, multiplied by our time. Don't forget to add this square. We now square it. So our time is having square. So you add the square to the 20. So half 0 multiplied by 20 is 0. So you don't have to input it. Plus 30 multiplied by 400. Multiplied by 400. I hope you understand. Half plus 30. 0 multiplied by 20 is 0. So there's no need of adding it. So, and 20 squared is 400. So S equals 2 divided by 30 will give us 15. So we are now left with 15 and 400. So 15 multiplied by 400 is 6,000. So we can't leave it like that. The unit of distance is meter. So we add the unit here. The unit of distance is meter. So we have 6,000 meters. So if we convert this 6,000 meters to kilometer, because our options are all in kilometer, to convert meter to kilometer, we divide by 1,000. And if we divide it by 1,000, we are left with 6. So it's now, so the correct answer is 6 kilometers. 6 kilometers. If I convert from meter to kilometer, you divide by 1,000. So if you check the option, Option A is the correct answer, which is 6 kilometers. Let's move to the next question. Question 2. A machine whose efficiency is 75% is used to lift a load of 1000 Newton. Calculate the effort put into the machine if it has VR of 4. What's VR? VR is the velocity ratio. So this is a simple machine question and this is a motion question. These two questions, JAMB repeat it every year. So be attentive. Let's start. Our efficiency is 75%. What next? Our load is 1000 Newton. Our effort is the small e. So the big E, the E in capital letter is the efficiency, while the small e is the effort. Our E is unknown. We are told to calculate our E. Our mechanical advantage is also unknown. Our VR, which is velocity ratio, is 4. So the formula for efficiency is MA over VR multiplied by 100. So jot this down. Just find a note to jot all this formula down. So when you forget any of it, you can quickly go and check your note. So we are looking for the effort. We are looking for what? Effort. How do we get our effort? Before we can get the formula for mechanical advantage is load over effort. Load over effort. So we don't have our mechanical advantage and we don't have our effort. And we don't have our effort. So how do we get our effort? We are left with only load. We only know our load as 1000 Newton. So we cannot continue with this. We have to know our mechanical advantage using this, since we have our efficiency here and our VR, which is velocity ratio. So let's just input it. So our efficiency is 75 over 100. 75%, which is also 75 over 100. This 100 also represents it. So there's no need of adding this 100 again. It's already here. Multiply by MA over VR. We won't write VR here because our VR is 4. We just change it to 4. So if we cross multiply, MA, which is mechanical advantage, multiplied by 100 is 100 MA, which equals 75 multiplied by 4 is 300. You need to know all these things of it. So when solving question, it will be easier to be solving it. So it won't take much time. So if we have to divide 100 by the both sides to get our mechanical advantage, 200 divided by 100 and 100 divided by 300 is 3. So our MA equals 3. So we already know our MA now. The next thing is to solve for our effort. Our MA is equals 3 equals our load is 1000 and our effort is unknown. We have our mechanical advantage as 3, our load 1000 and our effort is unknown. What do we do? Let's cross multiply. So let's bring it here. Our effort, 3 multiplied by our effort is 3 equals 1000. So let's divide both sides by 3. 3 cancel 3. So our effort equals 3 divided by 1000 is 333.33. 333.33 Newton. So that's the correct answer. And if you check our option, it's in option B. 333.33 Newton is the correct answer. Before we continue, make sure you have subscribed to Learn with Teacher YouTube channel as we move to the next one. Question 3. A quantity which requires magnitude and direction to be specified is A. Distance, B. Displacement, C. Mass, D. Temperature. So mass is a scalar quantity, temperature is a scalar quantity, distance is a scalar quantity. The only vector quantity is displacement, which is the correct answer. It says which requires a quantity which requires magnitude and direction. Distance, mass, and temperature only requires magnitude and they have no direction. But the one that has the two is displacement, and that's the definition for vector quantity. While scalar only have magnitude but no directions. Question 4. Which of the following material is a conductor? A. Plastic, B sodium, C wax, D glass. So what's conductor? To be able to conduct heat and electricity. And if we check the option, the only one that can conduct heat and electricity is sodium, because sodium is a metal and metal is a good conductor of heat and electricity. Question 5. Which of the following quantities has the same unit as watt? Which of the following quantity has the same unit as watt? A, force times time, B, force times distance, C, force times acceleration, D, force times velocity. Let's start from force times time. Force times time is the formula for impulse, which has nothing to do with watt. We all know that the unit for power is watt, and for force times distance, that's work, and the unit for work is joule. And for force times acceleration, it has nothing to do with watt. Also, force times velocity is the formula for power. It's another formula for power, and power, the unit of power is watt. Question 6. Which of the following is a pure semiconductor? A, silicon, B, phosphorus, C, transistor, D, carbon. So option A, which is silicon, is a pure semiconductor. Silicon and germanium is a pure semiconductor, or in the periodic table. So silicon is the correct answer. If you are watching this video up to this moment, please like, share and subscribe, and drop your comments in the comment section if you have any question to ask regarding this question. If you have anything to ask regarding this question, just drop it in the comment section as we move to the next one. Question 7. Transistors are used for the dash: A, conversion of AC to DC, B, conversion of DC to AC, C, amplification of signals, D, rectification of signals. Transistors amplify signals, and if we check the option, in option C, amplification of signals is there. So amplification of signals is the correct answer. Transistors are used for the amplification of signals, and for conversion of AC to DC, or to DC, or from DC to AC, it is the work of transformer. It is not the work of transistor. Let's continue. Question 8. The energy in the nucleus of atoms produce heat which can be used to generate A, mechanical energy, B, electrical energy, C, potential energy, D, kinetic energy. Potential energy and kinetic energy are still under mechanical energy. For those that have not watched the video which I did on work, energy and power for physics, go and watch it out right now so you can understand the concept which is in this question. So heat is the one related with mechanical energy. So mechanical energy is the correct answer, not electrical, because both potential and kinetic are still under mechanical. Mechanical energy deals with heat. Question 9. Which of the following waves has the shortest wavelength? A, radio waves, B, X-ray, C, infrared, D, ultraviolet. So guys, I'll be giving you an acronym to understand the concept of wavelength. You know this question is under electromagnetic waves. So let me write out the acronym. Gamma, extra, ultra in my radio. Gamma, extra, ultra in my radio. This is the gamma ray. This extra means X-ray. This ultra means ultraviolet. This in means infrared. This means microwave. Microwave is not in the option. And this radio means radio waves. So from here, if it goes up like this, it represents how the frequency increase, because gamma ray has the highest frequency while radio wave has the lowest frequency. But if it's going down like this, gamma ray has the lowest wavelength while radio wave has the highest wavelength. If it's going up, it increases the frequency, and if it's going down, it increases the wavelength. It increases the wavelength, while if it's going up, it increases the frequency. So if you have to check the shortest wavelength, you already know that if it's going down, it increases the wavelength. This is the highest wavelength. After that, microwave. After that, infrared. So infrared is not the shortest. We still have X-ray and radio wave left, and we still have ultraviolet. So ultra is the next, and after that we have our extra. So radio wave is the highest wavelength. So extra, which is also known as X-ray, is the lowest wavelength according to the option. But assuming we have gamma ray in the option, we have gone for gamma ray. I hope you understand now. Question 10. The process whereby a liquid turns spontaneously into vapor is called that. A. Evaporation. B. Regulation. C. Boiling. D. Sublimation. The correct answer is evaporation. Evaporation is the process of liquid to turn to vapor, which is gas. While regulation, some people will be saying, what's regulation? Regulation, for those that don't know, regulation is the process of ice to melt under pressure. For ice to melt under pressure. That's the meaning of regulation. So if you haven't subscribed, please find a moment to subscribe now as we move to the next one. Question 11. If a sonometer has a fundamental frequency of 450 Hz, so this Hz is the unit of frequency. What is the frequency of the fifth overtone? A. 2700 Hz, B. 455 Hz, C. 442 Hz, D. 75 Hz. This is one of the questions that is very simple in physics, but some candidates miss it. So if you see this kind of question, the first thing to do is to note the overtone. It is fifth, so our fifth overtone equals 6 multiplied by the frequency. You multiply it by the fundamental frequency. So 6 multiplied by 450 is 2700 Hz. As you see, guys, very simple. Assuming we have sixth overtone here, what do? You just write sixth, and you multiply 7, which is the next value, by the fundamental frequency, and you will get your answer. I hope you understand that now. And assuming the overtone here is 8, you have to multiply 9 by the fundamental frequency here. And if you check the option A is the correct answer. So if you have been finding this question difficult, I have made it simple for you guys. Question 12. Induced EMFs are best explained using A. Ohm's law, B. Faraday's law, C. Coulomb's law, D. Lenz's law. So Lenz's law deals with induced EMF. So the correct answer is Lenz's law. Lenz's law. Question 13. So this question is under angular velocity question. An object moves in a circular path of radius 0.5 meter with a speed, and speed is represented as v, which is velocity 1 meter per second. What is the angular velocity? So the formula for angular velocity is W equals V over R. This is the angular velocity, this is the velocity, and this is the radian. Let's input the value. Our V is 1 and our radius is 0.5. So our angular velocity equals 1 divided by 0.5 is 2. We can't leave it like that. So angular velocity is measured in radians. So radians is the unit. 2 rads raised by -1. So if you check the option, option C is the correct answer. I want you to note this formula. Find a note where you'll be jotting your formula. So anyone you forget, you just check your notes and easily remember it. It's very important. It's really helped me during my exam. Question 14. Clinical thermometers are examples of A. Pressure gas thermometers, B. Resistance thermometers, C. Alcohol thermometers, D. Mercury in glass thermometers. So the correct answer is mercury in glass thermometer. Clinical thermometers, which is being used in the hospital to measure the degree of hotness and coldness, is being used in the hospital to measure the degree of hotness and coldness of a body. So clinical thermometer are an example of mercury in glass thermometer. So let's move to the next one. Question 15. A car accelerates uniformly from rest at 3 meters per second square. Its velocity after traveling a distance of 24 meters is So this is a motion. This is a question under motion. I discussed that we have three formulas for motion. Here I said S in question 1, where I discussed the three formula. So if you are very attentive, you should be able to solve this question yourself. So as I am solving mine, be solving yours right there. So the formula, we are looking for our distance is known as 24 meter, and our acceleration is 3 meter per second square, because it says the car accelerates uniformly from rest. So we are looking for our velocity. Let me recap the formula I used earlier so you guys will be able to remember. I said S is equal to ut plus half at squared. This is the first one I wrote. The second one I wrote v is equal to u plus at. And the third one I wrote v squared equals u squared plus 2as. So if we check the givens, we have s, we have a, and we have v. The one that has s, a, and v is v squared is equal to u squared plus 2as. So that's the one that we are going to use. And we're also looking for our velocity. So our v squared equals u squared plus 2as. So our v squared is unknown. Our u is 0 because the question says a car accelerates uniformly from rest. So in your question, if you are not given your initial velocity, which is the u, and the question is stating that something is starting from rest, you should know it should be 0, because anything from rest is automatically 0. So our u squared is 0, and our a, which is acceleration, is 3 meter. We've already written it here, and our s is 24. So let's input it. Our v squared equals, our u squared is 0 plus our 2 multiplied by our acceleration, which is 3, multiplied by our distance, which is 24. So our v squared equals 0 plus 2 times 3 is 6, and 6 multiplied by 24 equals what? Equals 144. You need to know all this simple arithmetic. So you should be measuring in meter per second, but you can't stop there. You can't leave velocity with the square. So what do we do next? We square root it. If you square root it, square cancel this square root. So we are now left with our velocity. So the square root of 144 is 12. 12 meter per second is the correct answer. And if you check our option, it's in option D. 12 meter per second is the correct answer. Let's move to the next question. An object of mass 2 kg moves with a velocity of 10 meter per second. Our mass, the best thing to know is to write out our givens. Our mass is 2 kilogram, and our velocity is 10 meter per second, and our radius is 4 meter. So our centimeter force formula is mass times volume square, mass times velocity square over r. Don't forget to equate this square. If you leave this square and don't add it, there's no how you get the correct answer. So our centimeter force is, our mass is 2 multiplied by our velocity, which is 10 square, divided by our r, which is 4. So 10 square, you can just multiply 2 times 10, 20, and 20 square is 400. There's no how you get the correct answer. So 10 square is 100. 100 multiplied by 2 is 200. 200 divided by 4 is 4 divided by 20 here is 5. So our answer is 50 Newton. And if you check the option, it's in option A. 50 Newton is the correct answer. Let's check question 17. A wave that travels through stretched string like this, stretched string, is known as A, microwave, B, mechanical wave, C, seismic wave, D, electromagnetic wave. So the correct answer is mechanical wave. It travels through a stretched string. So if you have watched this video up to this moment and you haven't subscribed, what are you waiting for? Please subscribe now. Let's move to the next one. Question 18. A machine of velocity ratio 6 requires an effort of 400 Newton to raise a load of 800 Newton through 1 meter. Find the efficiency of the machine. So we have to find the efficiency of the machine. So guys, I'll be dropping a video on the topic simple machine. So this question, if you are not really understand simple machine, just subscribe to this channel now. So once I drop the video, you will be the first person to watch the video. So let's solve this question on simple machine. We are looking for our efficiency, and the formula for efficiency is MA over VR times 100. As I said earlier, because we've treated one question on simple machine earlier. So our effort is, which is the small is 400 Newton, and our load is 800 Newton. What other thing do we have? We already know our velocity ratio as 6. We are looking for our mechanical advantage. So the formula for mechanical advantage is L over E. To calculate efficiency, we need to know our mechanical advantage. So our load is 800 and our effort is 400. So 800 divided by 400 is 2. So our mechanical advantage is 2. So we can now proceed to solve. So our efficiency equals our MA, which is 2, over our VR, what's our VR 6, multiplied by 100. So 2 cancel 1, 2 cancel 2 will give us 1, 2 cancel 2 will give us 3. So we are now left with 100 all over 3. So 100 divided by 3 is 33.3, and efficiency is measured in percent, so we have 33.3%. And if we check the option, it's in option C, 33.3%. Let's move to question 19. The mechanism of heat transfer from one point to another through the vibration of the molecules of the medium is A. Convection, B. Conduction, C. Radiation, D. Diffusion. So conduction is the mechanism of heat transfer from one point to the other through the vibration of molecules of the medium. So conduction is the correct answer. Question 20, which is the last question for episode 1 on physics. During a thunderstorm, the sound is heard over a long time. The phenomenon is referred to as A. Refraction of sound, B. Reverberation, C. Superposition, D. Diffraction of sound. So once rain is falling and you are hearing that thunderstorm, and the thunderstorm is being heard for a long time, the sound of that thunderstorm, I hope you guys know it, everyone know the sound, that sound being heard for a long time, the phenomenon is reverberation. So guys, we've come to the end of this video. If you find this video helpful, please like, share and subscribe, and don't forget to subscribe now, so once I drop episode 2, you will be the first person to watch this video. And also share to your friend. Don't be selfish. Share this video to your friend that are preparing for this exam together. Share to your friend, share to your classmates interested or treating this particular subject. So I see you guys in my next video, and keep studying. Also keep learning.